Welcome to today's Explainer. We're cutting straight through the staggering amount of 2026 tech noise to look at the hard, unvarnished reality of AI and quantum computing. If you've been following the headlines lately, you know we're just inundated with breathless claims, massive funding rounds, and promises of revolutionary breakthroughs like every single week. But today, we're grounding ourselves entirely in the data. We're looking at what the benchmarks actually say, what the regulators are actively enforcing, and what the physicists are genuinely proving in the lab. And that really brings us to our core theme today. We are moving way past the hype and focusing purely on measurable realities. The era of just writing a blank check for a flashy proof of concept, that's completely over. In 2026, technology actually has to prove its worth. Whether that's an AI model demonstrating cost-effective reasoning, a corporation proving compliance with international law, or a quantum algorithm that can actually beat a classical computer. So here is our roadmap for navigating all of this. First, we'll cover benchmarking frontier AI models. Then we'll navigate the EU AI Act. After that, we'll dive into the truth about quantum ML. And finally, we'll wrap up with a toolkit on how to spot tech hype. Let's dive right in. Okay, Section 1, Benchmarking Frontier AI Models. We're going to take a look at the July 2026 data from BenchLM to see who is actually winning the AI performance race right now. Just to wrap your head around the sheer massive scale of the industry today, consider this. BenchLM is actively tracking 278 different large language models side by side across 253 unique benchmarks. This includes everything from complex agentic workflows and multimodality right down to highly specialized coding evaluations like SW Bench. We are way, way beyond the days of just comparing 2 or 3 major players. The ecosystem is massive, it's fiercely competitive, and it's completely fragmented based on highly specific enterprise needs. Now, look at this intense concentration right at the top. Anthropic's Claude Fable 5 currently holds the #1 spot with an overall score of 92. And you can see Anthropic and Google are just absolutely dominating this top 5 list overall. What this leaderboard really tells us is that, yes, the frontier of AI is definitely advancing, but it has become a remarkably tight race. The differences are literally being measured in incremental benchmark points across highly complex reasoning and deeply technical knowledge tasks. But here's the thing, raw intellect isn't everything. These top models are being measured on real-world operator trade-offs, things like latency, token costs, and context windows. A frontier model might be scientifically brilliant, but if it costs 10 times as much to run, or it takes 30 seconds to generate a first response, it's simply not going to win in a real-world enterprise deployment. It's fundamentally about finding the fastest, most cost-effective intelligence for your exact specific use case. Moving on to Section 2, Navigating the EU AI Act. It is definitely time for a compliance reality check, because this legislation has officially transformed from theory into hard law. This isn't some distant future problem anymore. The reality is here. As of August 2nd, 2026, we are hitting the primary deadline for high-risk AI systems to be fully compliant. The banned practices, those have already been outlawed since early 2025. Now we're standing in the critical window where high-risk systems, which, by the way, require rigorous conformity assessments that can take up to 12 months to complete, must be fully documented, overseen by human operators, and officially registered in the EU database. It helps to think of this risk framework kind of like a traffic light system. Unacceptable is a hard red light that bans things like biometric categorization by sensitive attributes or social scoring entirely. High risk is a bright yellow light requiring extreme caution and oversight. We're talking about AI used in vital areas like HR hiring software, credit scoring, and education. Limited risk requires basic transparency, like clearly telling a user they're talking to a chatbot. And minimal is a green light for basic applications like spam filters, which, thankfully, still represent the vast majority of AI out there. It is absolutely vital to know your role here, whether you're the provider actually building the software or the deployer who is just utilizing it in your company's HR department. You carry very specific, heavy legal obligations. For example, a US or UK company selling an AI tool to a European customer is considered a provider, and they have to comply fully with EU law. But even as a deployer, you've got to actively ensure your staff has adequate AI literacy and maintain strict use logs. You can no longer just plug in an API and forget about it. Because if you ignore these classifications, you could face maximum fines of 35 million euros, or 7% of your global annual turnover. That is a number that should instantly wake up any tech executive. The law is explicitly designed to make compliance less costly than non-compliance, which effectively makes the EU AI Act a de facto global standard. Companies everywhere are going to adopt this just to stay out of the crosshairs. All right, Section 3, the truth about quantum ML. Let's look at the hard science in 2026. We are shifting from the courtroom straight to the laboratory for this next reality check. This is an area where the marketing hype has completely outpaced the physics. Because quantum computers can theoretically process massive, multidimensional parallel states, everybody just assumes they'll instantly revolutionize how we train neural networks on giant datasets, right? We hear the word quantum and we immediately think infinite computing power. But despite the breathless headlines you see every day, this quote from a 2026 State of the Field analysis grounds us entirely in reality. It's a field with undeniable scientific promise, sure. But when it comes to the classical data you actually use in business, customer records, images, sensor streams, a true quantum advantage simply has not arrived yet. Check this out. In a recent peer-reviewed test, a basic classical logistic regression algorithm absolutely crushed the heavily hyped quantum models on 3 out of 5 real-world datasets. A classical random forest took a fourth. The quantum support vector machine won exactly 1. We have to be brutally honest here. Bolting quantum circuits onto classical datasets very often results in complex, super expensive models that lose out to algorithms you could literally run on your laptop in a few seconds. So the true advantage of quantum machine learning isn't going to be reading your customer spreadsheets. The real breakthrough lies in simulating molecular structures and actual quantum physics. When the data itself is fundamentally quantum, like in materials science, complex chemistry, or the raw output from a quantum sensor, a quantum computer can process that coherently in ways a classical machine just can't match. That is where the real frontier of this technology lives today. Let's hit our final section, how to spot tech hype. We want to give you a practical toolbox to navigate this incredibly noisy ecosystem. Because whether it's the next AI breakthrough or some wild quantum computing press release, you need a system to evaluate these claims rationally. When the next big headline claims a massive, world-changing breakthrough, how do you actually read it? You have to transition from being a passive reader to an active hype spotter. And the good news? You do not need a degree in theoretical physics to do this. You just need to ask the right questions to poke holes in the marketing veneer. You really have to apply 4 critical filters to any vendor claim. First, are they using real hardware or just a simulator? Because if it's a simulation, it's just a proof of concept. Second, was the classical baseline actually tuned, or did they deliberately handicap it to make their new model look better? Third, does their speedup survive the massive costs of data loading? Loading giant classical datasets into a quantum state can totally erase any computational time you supposedly saved. And fourth, is the dataset natural, or was it artificially constructed specifically to make the new algorithm win? If a claim fails these questions, it belongs in the lab, for sure, not in your enterprise business strategy. It all comes down to this. Always look to the engineers and physicists actually doing the rigorous daily work, rather than the marketing departments, to gauge the true maturity of the tech. The people building these frontier systems are incredibly excited about the future, absolutely. But they are also deeply realistic about the hurdles, like error correction in quantum or hallucination mitigation in AI, that still need to be solved before mass deployment. I really hope this explainer have given you the hard numbers and the right questions to ensure you are building on solid ground. Whether it's verifying AI model performance against your exact use case, auditing your current tools for strict EU AI Act compliance, or questioning the validity of quantum vendor claims, the power is entirely in your hands to demand measurable truth. So, as you look at your own organization's roadmap for the coming year, what will you evaluate first, and what hype are you finally ready to discard?